circling overhead. We do have a few patients we were trying to reach in Yarnell.
Yarnell Hill, Arizona, 2013. There were 19 firefighters that were battling a wildfire. They can't get away from the fire to their safe zone, meaning their safety route's been cut off. They have to deploy their shelters.
They knew that they had fire on both sides of them. They had fire behind them, and now they have fire ahead of them.
These shelters are only brought out when there's no other way out. So the firefighters will encapsulate themselves in it as the fire blows over.
Did they deploy, they say?
Yeah. We're talking minutes when they made this decision. And they were in a very tight deployment area. All of their shelters were pulled, and they all deployed at the same time, and they all died in this location.
We took note of a tragic loss of firefighters in the summer of 2013, and we thought if there is something that we're doing inside of NASA that can be worked in a little bit of a different way and have a bigger application out in the commercial world, we look at that opportunity.
Could we take this technology that we've been developing for a space application and transition it to support the needs of these entrapment shelters?
NASA's been working on a technology that is going to be enabling humans on Mars for exploration, and that's the inflatable decelerator. One of the key engineering requirements for that decelerator is to have a flexible thermal protection system.
There's a lot of common themes here between the flexible heat shield material that we work with here at NASA and the fire shelter.
So flexible TPS systems, it's really sort of like a thermal blanket is what it is. It's something you can compact, stow, put away, and then you use it when you have the vehicle actually enter into the atmosphere. And that's the technology we were working.
We're re-entering the atmosphere, and we need to survive that high heat rate for a very short duration of time. So is there any potential that we could use these thermal protection systems to improve these shelters that they're using for these entrapment situations?
Made a contact with the Forest Service about 8 months later, and that's where Chief started.
The difference between the technology that we've applied in the two areas, it's the same basic physical science that we're using on both sides, but the materials do change.
3, 2, 1, mark. We've tested over 290 different unique material layups. We call it coupon level testing. The ability to rapidly screen these materials, we've involved a lot of interns and volunteers, and students can get hands-on involvement in these types of projects and turn around 10 samples a day, and it's just great ability to learn from this test apparatus.
That peak temperature is not the real big challenge for us. The really big challenge, they don't want these systems to be very heavy. They can't be more than 5 pounds. They walk around with them all day. They're packed up on their sides. When they use them, they need to be deployed quickly.
Once we settle on some layups that we think are really worth looking at more carefully, then we pony up and build some full-scale fire shelters. Full-scale fire shelters placed in an enclosure, and there's basically propane torches that are used to simulate a fire environment around the shelter.
2, 1.
We usually have thermocouples to measure temperatures. We'll measure heat fluxes to make certain that the air in there is meeting the conditions that they need to have breathable air. And then we've had an opportunity to actually take the shelters out into a controlled wildfire area, set a forest fire that is a controlled situation, and then take measurements that are more realistic to what the firefighters would actually see in a deployment situation.
It's a life changer in this situation.
The benefit for both groups from this collaboration that we've had with the Forest Service is that NASA has been able to take some of the concepts that the Forest Service has been looking at and apply them and look at how they might apply to our entry systems.
I don't want them to have died in vain. I'm encouraged that we can all learn from this. I know that they would want us to all carry on. They would want the Granite Mountain Hotshots to live on and continue to protect lives and learn those lessons.